You were on Twitter at all, this got all the rage. Everyone's complaining about funnels here. What's interesting to note here, though, is that this is just a rotation about, let's say, the y-axis here. So what I'm doing is I'm taking some surface and I'm rotating this about the y-axis. Part A wants us to find the average value of the radius. Remember that the average value of any function is going to be 1 over b minus a times the integral of a to b of whatever my function is with regards to my independent variable. Here, r is a function of h, and h is ranging from 0 to 10. So for us, the average radius is going to be 1 over 10 minus 0 times the integral from 0 to 10 of my function 1/20th of 3 plus h squared dh. So this is going to be 1/10, and then I've got a constant 1/20th, which I can pull out. And I can integrate this. 3 is going to be 3h plus h cubed over 3, which we're evaluating from h equals 0 to h equals 10. So I'm going to have 1/200th of, now substituting h equals 0 into here gives us nothing, but substituting h equals 10 is going to give me 30 plus 1,000 over 3. Now this is my average radius, and of course the units for length in this problem is inches. So it's important to make sure that we include our units whenever we're given units. So this is going to be our average value of the radius, and this is a perfectly good answer. I don't need to worry about simplifying it. In part B, they want us to find the volume of a funnel. Well, remember that if I'm finding the volume of a rotation, I've got to add up all of these little cylinders where the surface, my base in this case, would be pi r squared, and my height is really delta h. So I'm going to be integrating from 0 to 10 pi times r, which is 1/20th of 3 plus h squared, times my height, which is delta h, or dh for our purposes here. Now, pi is a constant, and 20 squared is a constant. So I'm going to take the pi over 400 completely out. And I'm integrating from 0 to 10. This binomial is being squared. So that's going to be 9 plus 6h plus h squared. And I'm going to be integrating that with respect to h. And this is just a polynomial. It's pretty straightforward to integrate. So I've got pi over 400 times, it's going to be 9h plus 6h squared over 2 plus h cubed over 3, and I'm evaluating this from h equals 0 to h equals 10. So it's just a simple substitution. And again, as before, this h equals 0 is going to be really nice because all of these terms will drop out. So our volume ends up being pi over 400 times 90, I really should have parentheses there, 90 plus 600 over 2 plus 1,000 over 3, and this is going to be cubic inches. So that's all that we have to do here for finding the volume of the funnels, to treat this as a volume of rotation, because we're actually rotating about this axis here. And we're used to seeing things in terms of x and y, but what I've really got here is r and h. All right, moving on to part C, this is our related rates problem. It says the funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is h equals 3, the radius of the surface of the liquid is decreasing at the rate of 1/5 inch per second. That means that dh dt is negative 1/5. And that's important because we're talking about related rates, which means I need to take the derivative of this with respect to t. So I know that dr dt is going to be equal to 1/20th of the derivative of this, 2h, dh dt. And for our purposes, I know that h is 3, I know dh dt is negative 1/5, and I'm trying to solve for the rate of change of the height. Excuse me, this is dr dt, not dh dt. I'm looking for dh dt. So I've got negative 1/5 equals 1/20th of 2 times 3 times the thing that I'm trying to solve for. So I can multiply both sides by 4, so I end up with negative 4 equals 6 dh dt, or dh dt equals negative 4/6. And keep in mind that this is a rate of change of height, so this is going to be inches per second. And again, units are very important if we're given units.